For question number 1, you have to take the sample data available and beyond the numbers 3.30 Exhibit 1, which is on page 321 in the workbook, and perform a hypothesis test for a difference of proportions. More specifically, we want to see if there's enough evidence to conclude that taking Vytorin increases the chance of developing cancer, which is why there's a one-sided alternative. The workbook initially has this problem set up as a one-sample problem, but there are clearly 2 samples there, so we're going to do it as a 2-sample test. The first part in the wording after the sample data, about including unsimplified and simplified versions of the standard error, the reason for that is that the difference of proportions has 2 separate standard errors, one for a confidence interval and one for a hypothesis test. That's there to make sure you're using the correct one, the one for a hypothesis test. Then the test statistic, the p-value, which would have to be backed up with a StatKey screenshot, and the correct decision, either that you're going to reject or fail to reject the null hypothesis. This is worth 4.5 points. The way it breaks down is 1 point for the standard error, 1 point for the test statistic, 2 points for the p-value, and then half of a point for making the correct decision. If you want to make adjustments to the workbook and then work off of that, essentially we're just replacing the null and alternative hypotheses that are there. The null and alternative hypotheses that are typed out there in the workbook are for a single proportion test, but since there are 2 samples here, we're going to do it as a difference of proportions test. So if 1 denotes Vytorin and 2 denotes placebo, those hypotheses toward the left that I wrote in red by hand, that's what you want. Question number 2 is a hypothesis test for a difference of means, where we have sample data about the FOG index of 2 magazines, the Wall Street Journal and Sports Illustrated. The first thing to do is figure out if the data are paired or independent, which would dictate everything else. I tried to make that pretty accessible with the way the numbers are in the problem. Then, based on if the data are paired or independent, compute the standard error, then get the test statistic, then get the p-value, and make sure you have a screenshot of it. It's worth 4.5 points, half a point for if the data are paired or independent, 1 point for the standard error, 1 point for the test statistic, and 2 for the p-value. In question number 3, we have this sample data where we have 12 right-hand measurements and 12 left-hand measurements. There are 2 options there. Either those are 24 measurements where each person is measured once, 24 people who are randomly assigned to either use their left hand or use their right hand and have the reaction time measured, or this is 12 individuals where the reaction time is measured for both hands. One of those 2 scenarios involves paired samples, the other involves independent samples, and you have all the sample standard deviations that you might need right there in the wording, the one for right-hand measurements, the one for left-hand measurements, and the one for differences. So the standard error for one of them is 0.0061, and then for the other scenario it's 0.0423. To fill in the blanks, if you compute the 2 standard errors, so the standard error for paired samples and the standard error for independent samples, I think you'll get the 2 blanks in Part A pretty quick. Part B, if you have those 2 standard errors figured out and you know which is which, you'll get number 1 right away. And then number 2 and number 3 are a little bit conceptual, but number 2 you could figure out using the test statistic formula. Once you have the formula in front of you, that's mostly an algebra question. And then number 3, if you don't see it right away, maybe a little bit of trial and error, just using any t-distribution that you want to pick, I think you'll get that. If this problem is worth 2.5 points and there are 5 blanks, then it's half a point for each blank. Number 4 is ostensibly a hypothesis test where we're looking for evidence of a difference, because if you look at that third sentence to determine if overtime loads changed, so we're looking for evidence of a change, that's a 2-sided alternative. So you could do it using a confidence interval, and that's what we're going to do. That's why the confidence interval part is in bold, because you want to use a confidence interval here, not compute a p-value. The first thing to do is construct the confidence interval. Part A is worth 2.5 points, where it's half a point for the point estimate, 1 point for the critical value. In the screenshot, that would work out to half a point for the correct degrees of freedom, and then half a point for the correct percentile, or the correct proportion in the central region. Half a point for the correct standard error, and then half a point for the correct simplification. Then part B is worth 1 point, half a point for a yes or no, and then half a point for the why or why not. With number 4, the main thing is just to make sure that you use a confidence interval here.